problem is, for this use case, is how do we decide on a premium for a car insurance problem? So there is a company now, they have a lot of different vehicles they want to insure, and we want to charge them a single premium today, and that has to be based off of the expected loss that we would expect to see into the future. And there's many different ways we could go about this. So like bear that in mind as we go through this example, that this is just one way potentially of doing this. The thing we will need to consider to build out this model is all the blanks that we have here. We're going to be looking at a risk parameter and what the exposure is going to be. And we're going to model how the fleet size for this company is going to change. And then we're going to look at the total loss per claim. Let's just make sure that we can understand what these things are. So let's suppose this here, let's just give this as labels. This is going to be A, B, and C. These will be nice to just remember. So the value, what we should consider here. So let's imagine again, what is A? So maybe actually let's call this R for the risk. And let's call this E for exposure. And this is going to be the annual fee change. Much better. Wow, perfect. All right. So this is the expected claims per unknown vehicle. Now, we don't know what this is. Now, there's different ways one could find this. And we might have some regression model here that uses certain characteristics about this particular policy taker, company A, right? It could be the number of employees, it could be headcount, it could be growth, it could be location, so on and so forth. That might predict, let's say, the risk parameter, which is this expected number of claims that happens per a single number of vehicles, let's say. But it doesn't necessarily really matter where it comes from. The point is either way that there will be some uncertainty associated with that prediction regardlessly. This might also be something from a sort of an aggregated database that just looks at the rough sort of expected number of claims per many different, like across many different companies. And we'll use that as our baseline. So this is our starting point. And now we'll go up here at the top where we can see it says Evara. So I want to add an uncertainty. So the first thing we'll do is to have a choice of different sort of uncertainties that we could choose from. But in this case, we might consider a sort of exponentially decaying distribution. So in this case, we call that decline. And what it looks like, as you'll see, is it will going to start from sort of up here and it's going to go down exponentially fast like this, right? So we have a scenario value and we have the likelihood of it here. And in this case, if we say supposedly that we expect there to be about one claim per some unknown number of vehicles. It turns out that it's like 1 divided by the mean. That's really how you should think of this. That comes out of this uncertainty. So in this case, it's just 1 divided by 1. We expect that to be one car, but it could be anything from like all the way up to 4, and it gets like really unlikely that it's like greater than 5 here. So let's add that uncertainty here. Boom. Okay, now we can see it gets populated here. This is great, and it shows that expected mean value, right? This is the default behavior. Let's do the same thing now for the vehicle claim. So in this case, you might say that we expect on average that there will be like 10 cars that it was going to take for the, again, expected one claim to happen, right? But these are both unknown, right? They're both uncertainties. But we'll add this. It looks like this, so you can visually see what that looks like. We'll add it. You can see the number shows up here. So these are those two expected numbers. So this shows how easy it is to add something like changes in cars, because that's obviously important if you actually want to get an idea of what the future expected loss is going to look like for this insurance, for this company, company A. We don't expect it to be static, this number. So let's say, similar to before, we'll add this as an uncertainty. So occurrences, rate 5. Why? We expect there to be a growth of 5 cars in this fleet every year. But again, this number is also random. Actually, we don't know what this is, but this is what we would predict currently. So you notice that I've already written future here, just to kind of tie it in with how to use historical data versus new data and whatnot. So the way we started here, these will be our, we might call these all of our assumptions or latent variables. So with all these assumptions, this is our starting point. So this is kind of where we would begin, not having really any data. We're not looking at what this company has actually done historically. So it would be the starting point. Even with historical data available, we will simply have to predict, quote unquote, backwards, as you'll see here, right? So you can see we're going to make now predictions for the past years, assuming we might be in 2019, because this is how the model works, right? The model is, it technically doesn't care about what day it is today. It cares about the relationship between a prediction we would have made in the past to the observations we have from that time and then forward. And then as we go forward in time, we'll use the new data that's available and add it to the model here. But we'll refer to all these as assumptions. So now let's look at how many claims might happen. Now, if we want to predict the number of claims, we need to know firstly the number of actual vehicles that they have in the fleet. And from that, we want to actually predict the real number of claims. And so that will be, first of all, the R parameter divided by E, the expected, the number of vehicles per one expected claim, right? And then we multiply this by the actual number of vehicles. That is what we would do. But then this is just the sort of, again, it's essentially different rates. This is the expected number of claims now, given that we know how many vehicles there is in the fleet. And suppose we are in 2020, so our model needs to start somewhere. So here we'll just assume we know when that was back when they showed up at the office the first time, say, that they have 50 vehicles in the fleet. That's what we know. Oh, and I forgot to say that the loss per claim here is just assumed to be 15,000. This is for the next year. Now we're going to do this around. So the number of years here is going to be around the number we had above, plus the growth, of course. So what we've done here, if you look at the function, is that we've said it's actually a 10% variation, plus minus. So we just say that there is a chance that this is going to go even higher or maybe a bit lower. Okay. Now for the claims, we're going to do that thing that I just described, right? So we're going to be saying this is going to be Evara.occurrences again, be the risk parameter. Okay, and we're going to make it like this. Right, we're going to change it. It's going to be referencing the same number divided by this number, right? The exposure, right? And we're going to multiply that by the number of cars, C11. That's it. Enter. Now you can see the number of claims here in the first year. Again, we just showed you the expectation is nicely the number of cars, which is 50. Now we say on expectation that we expect one claim per 10 cars, so that is indeed 5, and we see this is exactly the number that pops up. So that's perfect. So now we're going to do this for every single other year. So we're going to just expand it down, and we can see that this is great, right? It grows by 5, the number 5 every single year. Now, similarly, it's very easy now to calculate the loss. That is simply, the number of claims multiplied by the loss, right? And similarly, we're going to drag that down. Now, we're going to do the same thing down here. So for instance, if we wanted to look at the total loss going forward, right, the predicted future loss, that would be just this number. But let's say this is actually the data that we observe. What's the new values for these? These are latent variables. This is what makes all our predictions into the future as well. So we want to update them. And we want to use these numbers now to make and update our model and our predictions. That is not a trivial task, and we can't just fiddle around with these. So we want to have something that can do this for us. So what we can do now is we can go back up here to our top and look at this, add actual. We'll do that. And then we want to pick the actuals. Click there. And I'm going to go to this other side and I'm going to choose them here. And you can see now they've been selected. I'm going to record them. And you'll now see these numbers, they change accordingly. And we'll do that for all the others. And that's all there is to it. So if we want to do a prediction now, what we can do is we can click run here at the top. And when we click run, it's going to automatically do everything it needs to do in the back end to make the changes necessary about these numbers. And as we now go down to explore the total predicted loss, now we see the total predicted loss is on expectation across all those future years about $780,000, right? With a standard deviation about 200,000. So this tells us everything about what we should expect to happen in the future. So if we want to be fairly certain that we are not going to lose money off a policy to company A, we should really use, I want to zoom in here, we should really use these set of scenarios to drive our decisions. So you see, if we're very, very generous, right, we might offer something down here. Now, if we are willing to take on more risk in that, it's quite likely that the loss is going to be greater, right? This is the loss again, remember, predicted B26 is the total loss for the next 5 years. By choosing, let's say here at this point, to be the premium, that means there's a very good chance that the loss is going to be greater. But again, the premium is smaller, so maybe company A is more likely to buy the premium. Whereas if we choose something that is higher, they may be less likely, but on the other hand, we will hedge our bets a bit more and make it less likely that we will lose more than the premium cost, so we can cover our losses. So if you were to do the pure premium strategy, as it's called, right, pure premium, then we would choose, that should be equal to the expected loss. So the expected loss over 5 years in this case, that is in this case roughly equal to, as you can say, let's just say 780,000. Oops. Right. So to give this company A an insurance contract, we would charge them, if we go by the pure premium, about $800,000 for it, which puts us in a situation where there's a good chance it's greater, but there's also a very good chance it's less than that. So it's a kind of fair, and it seems pretty symmetric as well, which is also very good, which means we kind of both accepting the same kind of risk. There's an equal chance that they will claim more losses than they're paying for the premium. We're both taking on the same amount of risk here by offering them the expected premium. This is where we can really start to play around with supply, essentially, and demand, and discuss with the internal strategic team how much risk are we willing to take on. And this is where it gets more complicated, where we might want to take some of these results and tie them in with other parts of the calculations and analyses and predictions of the organization, of the insurance company. Let's say we need to figure out what the reserves are required to be, because technically the reserves would really realistically have to be somehow reflective of the fact that there's a certain big chance that it's greater than this number, right? So if you look at that, you can see that if this chance, let's say, is about 50%, are we willing to bet 50-50 across many of such cases? So we can ask, what is the chance that it's greater than this? So we could look at that and see what are the confidence intervals. And this is where we have the export cells here. So that is just directly taken from this other sheet that has been exported. So we have access to those kind of results. Let's say that. But you can see here, and you can pick and choose the different percentiles, but you can see what the percentiles are, right? So there's a 25% chance that the loss is greater than about $900,000. And if we subtract whatever premium we charge them, then we have an idea of that there's a 25% chance that this is going to be the risk and the reserve that we'll need to have available to us. So let's say we have the premium here, and let's say that was indeed $600,000. Let's say then the profit is of course just equal to whatever we charge them for over those 4 years, like subtracted by that number, the actual loss. What we're going to see is that this is what we should expect to happen if we choose a certain premium. And this is where, and we won't do that today, but we might have another optimization stream later on, where we can choose the premium satisfying a certain criteria under this model. And this is where it gets even more interesting. But in short of that, for now, we can sort of just look at a visualization like this. And just like we said, it was about 880,000, I believe, if you looked at it last time. That is exactly what we see here. The mean is that we will lose if we choose the premium to be 600,000. So 180,000 is the delta from the expected value, which is perfect, right? That's exactly what we see here. It's 180,000. But the variance is quite large, which means, and this is one of these that looks somewhat a little bit skewed maybe, but still fairly symmetric, but there is a bit of skewness. It's not too surprising. But we can see that there is a good chunk of negative profit where we just lose money. And so this is where, if we choose our premium, we should be prepared to expect with high chance that we'll be in the hole. There is a not an insignificant chance that it's going to be close to $500,000 for this one company. And you aggregate that over a lot of companies, or people you give insurance to, then this can start to really ramp up. So I can choose to do any sort of utility function, right? I mean, I can choose to make this sort of any function of, let's say, the premium and the losses here, right? Say, I want something to be true about this utility. Bottom line is, whatever matters to the particular insurance company, you can answer all of those kind of questions and decide what is the premium you should charge, or what are the guidelines generally that you would give the actuaries and when you decide what you should choose. What are the criteria? What is the threshold of tolerance where you say we are happy if the chance of losing more than $100,000 is less than, let's say, 10% or 5%, that's our threshold, because that gives us an idea of like how much reserve do we have available to cover, and are we willing to risk it? And it's not clear that the best approach is to cover the worst case scenarios always, because that would be a way to do it, right? So if you look at the worst case scenario, which is way out there to the left, the most greatest loss, and we go back, you can see that is exactly 1.185 million. But then again, the chance of that is very, very, very small. So it's not clear that that's the best strategy, because then all that reserved money is not going to do other work for you. You can't reinvest it into the business and make better products or have it grow elsewhere, right? So that's, again, another layer you can look at. What is the relative chances of investing that money and being able to recoup that as well? And it's not just about expectations. It has to include all these variances and standard deviations and the shape of all of this.